Hello and welcome to this video. Today we're going to talk about factoring. Factoring is a very useful skill when you want to either solve for the roots of an equation or just solve for x. In most math classes, factoring is used on quadratics, which have the form ax squared plus bx plus c, where a, b, and c are constants. So let's take a look at some of the different ways that we can factor. So the first thing that we're going to talk about is the tree method. And I think it's best explained by doing an example. So let's say that we had x squared minus 3x plus 2. So let's set up our tree. So generally it's going to look like the c value, and then have our little branches coming off, and then we add whatever these numbers end up being, and then that should be equal to our b value. So in this case, our b value is -3, and our c value is +2. So our tree should have 2, and then we don't know what these numbers are yet, but they should be equal to -3. So we have to think of numbers that multiply to give us 2, but add to give us -3. So the only factors of 2 are 1 and 2, but 1 plus 2 equals +3 and not a -3. However, we also have to consider that -1 times -2 is 2, so then -1 plus -2 gives us -3. So those are the numbers that we should be using. So we should have -1 and -2 here. So those actually give us our factors. So we should have x minus 1 times x minus 2, and that's our factored form. So you could check by multiplying the two factors back together and distributing everything. Sometimes it's called FOILing. And it's important to note that to use the tree method, your a value actually needs to be equal to 1. So in this case, our a value was equal to 1, so we could use the tree method. And later in this video, we will talk about what happens if a is not equal to 1 and how do we deal with that. Now let's take a look at another method, greatest common factor, or GCF for short. To factor by the GCF, you need to take out the biggest term that all the terms have. For example, let's take a look at 2x cubed plus 8x squared minus 42x. First, let's just take a look at all of the numbers. So what do 2, 8, and -42 all have in common? If you said 2, you're right. So 2 is part of our GCF. Now let's take a look at all of the x variables. So for x cubed, x squared, and x, they all have an x in common. So the GCF in this case is 2x. So if we take out 2x from all of our terms, we're left with x squared plus 4x minus 21. And then we can actually use the tree method on this quadratic to get x minus 3 times x plus 7. And this would be our fully factored form. So GCF is usually used in combination with one of the other methods for factoring, not typically on its own, although it can be. So the next one we're going to look at is difference of two squares. So difference of two squares is more of a shortcut. You can still factor without knowing difference of two squares or dots. Using the tree method, this is just a quicker way to do it. You know you can use dots if you see something of the form a squared x squared minus c squared, and this factors into ax minus c times ax plus c. So, for example, if we had 49x squared minus 25. So this can be rewritten as 7 squared x squared minus 5 squared. So then by dots, our factors are 7x minus 5 times 7x plus 5. And so this would be our answer. So you can verify that this is true by distributing back out, but I'll leave that up to you if you wish to. So the next one we're going to take a look at is factoring by grouping. In order to factor by grouping, we're also going to need to be able to use the GCF. So we want to group terms together that have the greatest common factor. So for example, say that we had 6x cubed minus 3x squared minus 4x plus 2. So let's go ahead and group these first two together and then these last two together. So the GCF for these first two is going to be 3x squared, since they both have an x squared and they both have a 3. And then the GCF for these last two is going to be 2, since this 2 doesn't have an x, so we can't pull any x's out, but these both have a 2. And then I'm also going to make this a negative 2, and you'll see why in a second. So if we pull out 3x squared from the first two, then we get 2x minus 1, and then if we pull out a negative 2 from these last two, we get 2x minus 1. So this is good because we want these two to match, the 2x minus 1s to match, because then that becomes the new GCF. So this whole term is now a GCF. So we take that out and we get 2x minus 1 times 3x squared minus 2. So that is our factored form. Sometimes you'll have to move terms around in order to get the best combination of GCFs. It's all right to try a couple different ones. Typically the best ones to group are the ones that have the most powers of x in common. So the last method that we're going to talk about is called the AC method. So remember we talked about at the very beginning that the standard form of quadratic is ax squared plus bx plus c, where a, b, and c are constants. And if you remember back to the tree method, you'll notice that it only works if a is equal to 1. So the AC method deals when a is not equal to 1 and combines both the tree method and grouping. So let's take a look at this example. So say that we had 8x squared minus 10x plus 3. So in this example, our a value is 8, which means that we can't use the tree method since 8 is not equal to 1. And there's not a GCF for all three terms, and it's not a difference of two squares. And we can't really see if anything should be grouped, if they can be at all, so this leads us to the AC method. It's the same idea as the tree method to start, except we have to make sure we multiply it and use AC as opposed to just C. So in general, we want AC and then branch off to our other terms, and then that should equal B. So in this case, our A value is 8, like we said before, and our C value is 3. So 8 times 3 is 24. So we have 24, and then we don't know what goes here yet, but we do know that we want that to be equal to negative 10, which is our B value. So we need factors of 24. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. So 1 and 24 aren't going to give us 10 no matter what combination we do, so that's out. 2 and 12, if we could do 12 minus 2, that would give us 10, but there's no way to get negative 10 from those two, so that's out. 8 and 3 don't give us 10, but if we add 4 and 6, that does give us 10. But since we need it to be negative, we're going to use negative 4 and negative 6. So let's see, and double checking that if that works. So negative 4 plus negative 6 gives us negative 10, so that's good. And then negative 4 times negative 6 gives us 24, so that's good. So that actually splits up our b value. It doesn't just give us the factors this time. So we'll have 8x squared minus 4x minus 6x plus 3. So if we were to combine these, we would get back our negative 10x. But now we can actually group. So let's group these first two together and these last two together. So these first two, let's take out a 4x. So we get 2x minus 1. And then let's take out a negative 3 here for the last two. And then we'll get 2x minus 1. And since these are the same, now we can take 2x minus 1 as our GCF. And then we get 4x minus 3. And that is our factored form. Okay. So I do have practice problems in the transcript of this video that is in the description, along with the answers. If you'd like a more in-depth video on how to get the answers, let me know. And then if you're a UNT student, there'll be some resources that you can check out in the description. But that's all for this video. Thank you for watching, and goodbye.